This conference will now be recorded.
Hello, everyone. Brian Gockel here, Weather Service Office of Observations. Welcome to the Satellite Book Club Seminar Series. This is session number 218, and today's presentation is Applications and Analysis of CIRA and NOAA Satellite Moisture Products for the recent November 2024 West Coast Megastorm. Presenting today is Sheldon Kusselson, retiree from NESDIS SAB and part-time research associate with CIRA. And our facilitator today is William Straka, researcher from SIMS. Thanks for both of them for joining us. Before we get underway, this session is being recorded as usual. Please mute your microphone and turn off your webcam if you're not a presenter or speaker or facilitator. The Q&A section will be after the presentation as usual, and we encourage everyone to put any questions or comments you have in the chat room, and the team will field them from there. We'll address them in order at the end of the meeting. If you are logged in under an alias account, please sign in with your full name or specify your full name when asking a question in the chat. We're always looking for presenters for future book club seminar series or seminar events. So please contact the TOWRES team if you are interested and available to present. Emily's dropping a link to the presenter facilitator form in the chat, so you see it there in the chat. And the training team can help develop training materials or provide available training materials that either unavailable, or if you can't locate them, they can help with that as well. Please contact Ross Van Til for information about that. Thank you to the OCLO, the GEO and LEO programs, and our facilitator, William Straka, today. So before we get underway, just a few words about Sheldon. Sheldon is currently working part-time as a research associate at CIRA, supporting new satellite products for forecasters. Before he retired in 2015, he worked for 36 years in the NESDIS Satellite Analysis Branch, where he provided operational satellite moisture and precipitation analysis and short-term forecast guidance in support of the Weather Service. He was a pioneer in the use of microwave data in the forecast process, and is estimated that Sheldon provided over 13,000 satellite briefings to NCEP WPC, HPC WPC. He provides guidance and expertise on the improvement and development of satellite moisture and rainfall products for moisture. Sheldon, welcome back to the Satellite Book Club.
Thanks, Brian, for that warm introduction. I will first briefly talk about the long but satisfying road to develop satellite advected layer precipitable water, ALPW for short, for forecasters. Then, in the context of last month's multi-day megastorm that battered Northern California and Southwest Oregon, also gave some pretty strong winds to the northwest part of the United States, and with heavy precipitation, provide information, including some graphical analysis and applications of the ALPW product, upgraded blended TPW, and some new experimental CIRA satellite moisture products. Next slide. Back in 2010, when I was still working for NESDIS, John Forsythe of CIRA asked me to write a recommendation for a new layer precipitable water product he wanted to develop. Here is the recommendation I wrote for a NASA proposal. The points I made that recommendation letter ring as clear today as they did 14 years ago. Forecasters need to know where and how much moisture is at various levels to forecast destructive heavy precipitation. Knowing how deep the moisture is at various layers will help forecasters improve the timing of these events. Just as important as timing, a layer precipitable water product would give a better handle on the location of the heaviest precipitation. Also, knowing the length and depth of moisture at various layers will tell a forecaster if an approaching storm will be ordinary or extraordinary. Next slide. Here is a brief history of the CIRA layer precipitable water product. From motivation by the blended TPW product that first went operational in 2009, to getting forecaster feedback almost from the beginning when imagery was developed and put on the internet, to making it an advected product for improving its timeliness for forecasters, to developing teletraining and a quick guide, to having it evaluated at various test beds and proving grounds, to developing lots of cases, studies with analysis and applications shown on posters for conferences, presentation talks at offices, and meetings for tropical storms, excessive rain, severe weather. Showing the experimental product on the internet was not enough, so we found a way to deliver the product to requesting NCEP centers and 27 National Weather Service offices for more intense day-to-day use and evaluations. Next slide. Fast forward to 2024. Advected Layer Precipitable Water became operational in NESDIS last October, and now will become officially operational in all National Weather Service AWIPS workstations, hopefully in February, to help forecasters analyze and forecast heavy precipitation, severe weather, tropical storms, and especially to uphold NOAA's objective of saving lives and property. Next slide. Here will be the configuration image on your local AWIPS workstation for ALPW. I can tell you that when I visited the National Weather Service Sterling, Virginia Weather Service office back in 2018 to give a winter weather talk, I got my first view of the then experimental product on their AWIPS workstation via CIRA and NASA Sport. They, along with NCEP centers and 26 other National Weather Service weather forecast offices, have been providing valuable feedback to us so we could make the product better for forecasters. Next slide. Not sure the configuration graphic of ALPW will look quite like this, but this is how it looked at NCEP WPC when I visited them in early October. Now let's look at blended TPW, ALPW, and some additional moisture products for the recent multi-day megastorm system that brought flooding rains and blinding blizzard snows to the West Coast last month. Next slide. The headlines from the BBC on November 22nd were, quote, atmospheric river dumps snow and record rain on California. An atmospheric river swept through Northern California, dumping record rain and deep snow in the region. In Santa Rosa, California, the 12.5 inches of rain shattered the 3-day record of about 10 inches set in October 2021. Remember October 2021 for later on. I will start first with upgraded blended TPW, then talk about ALPW. Then I will show some recently developed CIRA experimental satellite moisture products, also with applications and analysis for last month's mega West Coast storm. Next slide. Sure, satellite is most useful for short-term forecasting. However, I found it worthwhile to go back a number of days in time with the current satellite TPW imagery. This was to track the mid-latitude or subtropical moisture disturbances that could cross the Pacific to possibly become a major storm by the time it reached the U.S. West Coast. The circles on the blended total precipitable water product tracked the November mega storm disturbance for 9 days, starting from the southeast China coast on November 12th to the monster storm it would become over the northeast Pacific by November 20th. Next slide. Blended TPW has been an operational satellite product on National Weather Service AWIPS workstations since 2009. Come this spring, an updated version, like seen here in the center part of the slide, will replace the current blended TPW in your AWIPS. The biggest changes for this updated satellite TPW product are the inclusion of GFS winds to advect the TPW to the time of the image, to make it more accurate and timely. and also the addition of GOES ABI TPW over the CONUS. As you can see from the larger movie loop in the center, it does a very good job of observing the different aspects of the atmospheric river that affected Northern California and Southwest Oregon, with multiple days of record-breaking lowland heavy rain and mountain snow. And look to the right and compare with another atmospheric river event that occurred in October 2021. Next slide. Like the blended TPW product, the Advected Layer Precipitable Water product should also allow you to follow disturbances like with last month's storm, or any storm anywhere that could affect your area in the future. Think of it as a check on how the models have initialized the storm's moisture progress up to the current moment. As you can also see, the Advected Layer Precipitable Water product, slated to be officially in your National Weather Service AWIPS workstation soon, should allow you to follow these disturbances moisture in 4 layers of the atmosphere for days leading up to the event in your area. Next slide. Here are some characteristics of the Advected Layer Precipitable Water product, along with a 4.5-day movie loop of the storm that affected the West Coast last month. The product separates the total precipitable water into 4 distinct layers. Each layer's precipitable water moisture is advected by the GFS winds, the only model used to produce the product, to the time of the image. It complements and supplements the TPW product by giving you more of the depth of the moisture. Yes, most of the atmospheric moisture usually resides below 10,000 feet or below 700 hectopascals. But when a relative maximum of precipitable water moisture is above 10,000 feet and located over the same area as the low-level precipitable water moisture, that extra amount of moisture in the highest layers can make the difference between an ordinary heavy precipitation event and an extraordinary one. Next slide. Here is an analysis on the layer precipitable water product where I placed average wind streamlines through the highest moisture of each layer to locate where the heaviest precipitation may fall downwind over the next 12 to 24 hours. This kind of analysis has worked well over the last 30 years for TPW and the past 10 years for ALPW for best moisture transport and efficient rain production. With 4 layers, the depth and contribution amount of precipitable water moisture provides additional valuable information to the integrated or total precipitable water. Next slide. LEO satellite microwave moisture products have been around since the late 1980s to provide added value to geostationary satellite imagery. Use of the LEO microwave ALPW with the approximate same time GEO and also the GEO image compared with the ALPW loop helps forecasters get a better handle on the storm to improve overall meteorological analysis and forecasts. Next slide. NCEP centers like WPC and the National Hurricane Center have been evaluating and using ALPW product for years. The ALPW product, along with CIRA researchers, have participated at the Summer Flash Flood and Intense Rainfall and NSSL Spring Hazardous Weather Testbed experiments. And this winter will do the same for the Precipitation for Atmospheric Rivers experiment. Here is an example of messages sent out from WPC MetWatch desk making use of the ALPW product in their discussion of heavy precipitation for the recent West Coast flooding event. Next slide. I know my talk today is mostly geared toward National Weather Service people, but let's not forget about our meteorologist partners. I try to communicate with them as well to let them know about the additional satellite moisture products that are out there on the internet, but not provided to them by the weather vendors. A few days before last month's West Coast storm, I got an email from a California TV meteorologist friend. He told me the ALPW product from CIRA was not updating on the web. After we got it updating a few hours later, his reply email was marvelous, and I quote, "I rely on this display to visualize moisture levels in the atmosphere. Very important with what is unfolding over the North Pacific as we speak." Big exclamation point. Except for the internet, the media does not see some of these satellite moisture products like National Weather Service forecasters do on their AWIPS workstations. Next slide. CIRA did not rest on its laurels after completing work on operational advected layer precipitable water. One of the most important ingredients for heavy precipitation is integrated vapor transport. With the establishment of the layer precipitable water and now multiplying average model winds through each layer, a satellite vapor transport product for 4 distinct ALPW layers was developed 2 years ago to see more depth to the transport of atmospheric moisture. Think of it as a steady stream of water vapor coming in as precipitation is continually squeezed out. This has allowed us to come up with a pattern recognition conclusion about the generation of excessive precipitation from this product. Long fetch, persistent, maximum moisture transport near the same area on 2 or more layers like seen in the satellite vapor transport movie loop can many times mean excessive, even extraordinary catastrophic lowland rain and blinding higher elevation, cold season, heavy snow some distance downstream over the next 12 to 24 hours, which happened with this recent case. Next slide. Here is another way to look at it. It's like attaching your faucet to the end of a very long water hose and opening the spigot all the way. You continually replace the water or snow released from the atmosphere to the ground. If done for more than a day, like with this event, excessive rain and or snowfall occurs, like it did with over 2 feet of snow and over 20 inches of rain over multiple days. Next slide. Here is another new CIRA satellite moisture product called ALPW Percentile Ranking. Key points include taking each of the 4 layers of precipitable water and comparing them to a recent 11-year satellite climatology. The greater than 95th, greater than 99th, and record-breaking percentiles are colorized to see where the exceptional precipitable water moisture at each layer was located based on the climatology for the time of year. Note that 2 or more layers of persistent greater than 95th percentile does well with identifying exceptional heavy precipitation areas as long as there's some forcing mechanism present. This loop shows how persistent the well above normal precipitable water values were at most of the 4 layers. Next slide. Lastly, here is a reference page that includes internet sites for some of the moisture products mentioned in this talk. In addition, there are reference guides, training sessions, publication links, especially for ALPW that will be on your AWIPS workstation soon. Take advantage of this information as it will help you better understand the satellite moisture products shown in this talk. Thanks for your attention.
Thank you very much for your presentation, Sheldon. It was
Thank you.
very interesting, as always, to learn about the ALPW. Uh, I do want to mention that we will be going to the discussion section here in a little bit. I would encourage those of you from the field forecast offices and regional headquarters to put any questions you might have into the link. And I also do want to remind people that a week from today is December 19th is going to be a presentation from Tim Schmidt, the imagery goes our imagery team lead. He'll be discuss a GOES view for 2024 and glimpse into 2025. Those of you that know Tim, he is retiring at the end of the year, so this is probably going to be his last presentation as a federal employee. And also, please, if you have, please contact the Tower S team, Kashad Bowman and Emily Maddox, for any questions about the Satellite Book Club and for configuration of satellite products. While we wait for people to put in their questions into the chat, I do have, well, my first question is already covered because we were talking about how we're going to get the CIRA ALPW into the regional LDMs, and Lee already mentioned that, and you already covered that. But one of the things that for the last 30 years, you've collaborated with the researchers and helped with the development of satellite moisture products like the blended TPAW percent of normal TPW, snowfall rate, and the list goes on. Which of them, and of course you can choose more than one, has been your favorite for helping forecasters with presenting how for forecasting health precipitation?
Well, William, that's kind of a loaded question. They're all pretty important. I thought that doing blended TPW and getting it operational back in 2009 was the height of anything. I was ready to just stop doing any more developing with my colleagues at CIRA satellite moisture products with the blended TPW, and then like a few days later I realized, well, there's more to come, and a couple of years later, John Forsythe told me to write a recommendation for layer precipitable water, which seemed very intriguing, and I've enjoyed helping develop that too. So all of the satellite moisture products that I've developed with other people, and I say developed with other people because I couldn't have put in my 2 cents with these products if it wasn't for the people who developed the imagery for these products. So they're all my favorite. Short answer.
Yeah, great. And I know we appreciate your helping out in the research for those many years. Brian Curran, and I can't, his name, the WFO office ends right off the edge of the screen there. But he's one of the SUs there, and he has, Midland. There we go. Thank you very much, Brian. He was saying that, out on the plains, you can see where the surface and 850 millibar moisture profile can indicate where the dry line is. But, what other uses do you envision for these products for severe convection?
The most important, and I have to admit, I'm not a severe weather expert. My training and my work, my day-to-day work when I worked at NESDIS, and also now my work working at CIRA has been with precipitation and moisture and things like that. But the biggest thing to me for the ALPW product is locating the elevated mix layer and comparing it with the GOES 7.3 micron. Also, that is very good for finding the dry area of that elevated mix layer for severe weather. So, Dan Bikos has done a wonderful job of with training material for that for the uses and application of the ALPW for that product. So the elevated mix layer is the big thing that ALPW helps out, and overlaid on that with by looking at the low level part of the ALPW, the high moisture, and where those two intersect is where the best chances of severe weather are. So those two aspects of the ALPW product, the low level, the very high moisture in the low levels, and the very dry air at the especially at the 700 to 500 layer for the elevated mix layer, will help you immensely, along with looking at obviously the geostationary imagery for severe weather.
Yeah, thank you, Sheldon. And I do also want to mention, if you want to, if the audience would like to ask your question verbally, please feel free to raise your hands, and
Yeah.
get you.
I like questions, so don't be afraid, even if they're easy questions or hard questions. I don't mind questions.
Yeah. Perhaps while we're waiting for some more questions, thank you, Scott, for putting in a question. We're right to these. He's asked, ALPW has 4 products, 4 levels, and that is a lot of clicking for an AWIPS terminal. Which one do you think is the most important for forecasters?
Okay. It'll all depend on the situation of the day. When you come into the office, could be an easy day. You may not even have to look at the ALPW product unless you're interested in dryness and where the dryness is at what particular layer. If it's going to be a flooding day or something, or some kind of flooding, heavy precipitation coming in the next few days, I would first start with the low levels, the surface to 850, and if you're in a location or your WFO area is mostly above the 850 level, I would start looking at the 850 to 700 layer of precipitable water moisture, and then work my way up. If it's going to be very dry in the high layers, then you really don't have to worry too much about that, unless it's going to be a severe weather day where you'd want to look at the 700, 500 to look for the elevated mixed layer dryness, along with the geostationary 7.3 micron imagery. So that's the best way I would look at things.
And I'm sure that these are the sort of what to do for different for different types of days is covered also in the training that's provided.
Yeah, like all types of satellite products. It depends on what the day is going to be like when you come into the office. Whether it's going to be an easy day or a very, very difficult day. You pick and choose the satellite products that are going to give you the best bang for the buck for helping you out with the forecast. And that forecast obviously includes the models, and you're going to have to kind of see if the satellite is in sync with the model, what the models are forecasting, or maybe tweak things a little bit toward the satellite.
Yeah, and I think Scott also followed up with the question of maybe if there's a way to combine the information from the lower 3 levels into a sort of an RGB that somebody could quickly sort of look at what's going on and then sort of be able to then move on, delve into the more detailed information at the different levels.
And also I starting out with the total precipitable water, the satellite total precipitable water product, is kind of what I've done throughout my career, and especially when I was working operations in NESDIS. I would start out with the total precipitable water, but then I wanted to see what the moisture was like at the 4 layers of that total precipitable moisture. To get a better handle on whether this was serious moisture with an atmospheric river or or going to be an extraordinary atmospheric river or whatever amount of moisture that could produce excessive amounts of precipitation in my area for for the next day or so, that type of thing.
Thank you for that answer. It's really a lot of information that's contained in there in those products.
Yeah, one other thing, and I have to say that the revised blended total precipitable water product, we finally got together a few years ago with people from SIMS, Mimic TBW, and the Mimic TBW people, Tony Wimmers especially, and it's a collaborative project to bring in some of SIMS's ideas about vecting precipitable water and making the new operational blended TBW product that will be in your AWIPS workstations hopefully around spring. Make it even better and more pleasing to look at than the current ALPW product. So the blended TBW product has been a collaborative enterprise over the last few years with University of Wisconsin SIMS and Tony Wimmers helping us out with that.
Thank you very much. I just want to check to see if anybody has their hands raised. I don't see anybody. So maybe one last question, just to in the November case, you showed that the affected region in California was it was in Northern California, where you had the winter storm was in Northern California and Southwest Oregon, but then there was heavy moist rain at in the lowlands with so you had that differential. That differential, right? And what stood out to you that would maybe present how that storm would evolve, so how that because it's a very complex situation. What would how much what sort of lead time would you have for knowing you're going to get heavy snow and flooding, because it's very complex for a WFO to be able to handle those things.
Well, before we CIRA started developing this ALPW Layer Vapor Transport product, we had to overlay winds at the particular layer, streamlines to get a feel for the layered part of the vapor transport. So I actually think the vapor transport may have a slight edge on giving you some really good lead time on excessive amounts of precipitation, because that layer vapor transport is telling you at least the maximum amount of that layer vapor transport is telling you that moisture and water vapor that's coming in is immediately coming in to replace what's falling out. So big time layer vapor transport and particular layers are important. Obviously the low levels are going to be the most important, but even the high layers where moisture is coming in to replace the moisture that's been falling out, even at the highest layers, maybe be extremely important in giving you a heads up 12 hours, maybe as much as 24 hours ahead of time before it does it on the ground, inland, and in this case, in Northern California and Southwest Oregon. So lead time, I think most of these products can give you some pretty good lead time, at least 6 hours. And in the case of vapor transport, maybe as much as 12 to 24 hours. And the same thing with the ALPW, if you overlay winds on the ALPW and at the particular layer, and also overlay low-level winds on the blended total precipitable water, because that's where most of the moisture resides, with the total precipitable water moisture.
Great, thank you, Sheldon. I don't see any other questions, so I will pass it back over to Brian Gockel for some concluding remarks.
Okay.
All right. Thanks, William, for your facilitation today, and thanks to Sheldon for the informative presentation on the satellite moisture products. And Sheldon, thanks also for your decades-long commitment towards these product developments with the cooperative institutes and NESDIS. Your product improvements, been hearing your name for a long time in a positive way, and your work has been tremendously beneficial to the Weather Service forecasters.
Thank you
and
very
of course,
much, Brian.
as Lee
Thank you
said in the
so much.
chat, we are working hard to get that layered precipitable water product out on the SBN and into all the offices, so it'll be operational end to end. Only a few satellite products a year make it to the top of the heap in terms of operational to all offices. And so we're glad to help push that one over the finish line for the users. As William mentioned to us a few minutes ago, please join us a week from today, Thursday, December 19th, same time, for Tim Schmidt's view of GOES in 2024 with a glimpse at 2025. That's sure to be another interesting brief. And with that, I think we can wrap up today's seminar. Thank you all for joining, and we look forward to seeing you a week from today.